Hi, my name is Matthew Puentes, and today I'll be giving my GRIE presentation on my thesis. My thesis's title is PEGASUS, which stands for the Powerful Expressive Graphical Analyzer for the Single-Use Server. The idea for this thesis emerged from a problem that we saw with modern website development. As the web has become more and more popular over time, the tools that we use to create online platforms have become more popular as well, leading to more features, users, and websites than ever before. This increase in scale has an associated increase in complexity, with modern web development frameworks, such as WordPress, having thousands of files and directories of PHP code in a base install alone. Web applications also have unique complexities to them, such as the asynchronous nature of their design and their reliance on multiple technology stacks. These problems have all led to it being difficult to debug a web application, meaning outages, errors, and even security vulnerabilities can be difficult to detect and can be difficult to fix. There are existing tools that seek to aid in mitigating bugs in web apps, such as Radiatus, Clamp, and the single-use server. However, all those tools focus on mitigating and detecting errors, and stop short of actually helping the developer fix the bug. This presents a gap in existing work, which Pegasus seeks to fill. Pegasus will be designed to understand and simplify the debugging question in order for us to investigate how much labor we can take off the developer during the debugging process. The research question I'm using to guide this work is how precisely can we identify and communicate an error in a code base using the single-use server infrastructure. As a quick example to demonstrate the need for further work, we ran a known CVE on an installation of WordPress that was running with the single-use server. After the CVE was run, the single-use server had a variety of logging information that could be used to help find the bug. However, this information was extremely dense and verbose, with hundreds of lines in some logs and entire megabytes of unformatted data in others. This is to be expected of most logging systems, which aim to be verbose to catch everything, but it presents a huge amount of labor for a developer, when the data sources could, and generally should, be easily filtered and simplified. Pegasus should be reducing the developer's data fusion problem by distilling information into different levels of complexity. Additionally, by allowing movement between levels of complexity, it will remove the need for multiple different debugging tools. Pegasus will use several different layers of abstraction and complexity isolated into their individual components. The user will be able to compose and resize components as needed in order to fit their workflow, and each component will coordinate with every other component to give the user multi-level views. The first component that we've designed will be a code graph, which will be a representation of the function logs that the single-use server generates. By stripping out all functions that don't occur between the code flow starting and the detected error, and trimming functions that are unnecessary, such as ones that complete with no side effects, we can show the user a streamlined view of the program, allowing for easy navigation and selection of potential suspects. Next, we can generate flame graphs, which are an easy way of representing the entire program execution efficiently. This will be available to help users gain an understanding of what a program was doing prior to failure, and just generally allow for explorative data collection. Finally, we can show the user the actual code view, which will act much like a traditional IDE. It'll be a syntax-highlighted annotation system, allowing for the user to note potential errors in the code itself as they explore through other views. These annotations will be the end result of Pegasus, as after a developer annotates and notes where the problem is in the code, they can just debug it through their already existing workflow, or even package the annotation and send to another developer. Pegasus will also do data processing behind the scenes to mark some code sections as suspicious. Finally, this is a rough mock-up of what the Pegasus UI might look like, composing different components of different complexities together to give one development experience. That's my proposal for Pegasus. It's an investigation into how much we can reduce developer burden using the single-use server dataset, which we will attempt to do by composing different levels of abstraction in an easily understood manner. We will consider it a successful project when we can narrow down a known CVE into 10% of the WordPress code base, representing a reduction in effort. Thank you for taking the time to view this video, and I look forward to getting your feedback.